All right, let's get started. Thanks everyone for coming to my session, Transforming Your Web Applications with Reactive Functional Programming. You made it through the mouthful of a title. That's excellent. I thought I was going with a play on words. I wanted to link transform with the functional programming, but I think I lost it in the length of the title. I want to start out with a clarification about what this talk is not about. This is not about React, which is the web framework that Facebook put out recently. This is instead a talk about reactive programming using in JavaScript using the Rx.js library. So what we're going to talk about today, we're going to start with a brief review of asynchronous programming with JavaScript, look at current standard state-of-the-art tools in writing asynchronous JavaScript code. We're going to introduce observables, which is how we're going to handle asynchronous JavaScript in this session today, and we're going to wrap it up with some use cases and some examples. I'm Brian Leathem. I'm a software engineer at Red Hat. I previously worked on JSF-related technologies, spending a lot of time recently on the working in JavaScript environments, Node.js on the back end, JavaScript clients in the browser, and so on. If I could get a feeling from who we have here in the audience, can I see a show of hands from who considers themselves proficient with JavaScript? All right, that's good. And who is familiar with functional programming in any language? All right, good stuff. So with that, with those introductions out of the way, let's dive into the good stuff. So as you may or may not know, JavaScript runs in a single event loop. If we ever want to run any long-running tasks, we don't want to block that event loop and lock up the browser. So we have asynchronous JavaScript, which allows us to break out of that event loop. So some typical use cases that we see with asynchronous JavaScript are AJAX requests to the server, any animations we want to render in a browser, the window set timeout, set interval methods, or is registering event listeners for keyboard, mouse events, that kind of thing. And there's a whole host of new async APIs that are being introduced with the latest JavaScript versions and HTML5 improvements. The standard means for working with asynchronous JavaScript code is using a callback. So if you're providing a callback, you will take as a parameter, sorry, if you're providing an asynchronous API, you will take as a parameter into your function a callback function, which you will invoke when your long-running task is done. So invoking the callback then tends to look like this. We'll call the function, we'll pass it some arguments, and then we usually use an anonymous function to define the callback that we want to execute when our task is complete. So this for one-off events like a AJAX call, this tends to work well. Where it tends to break down is when we want to combine various asynchronous events. So you may have seen this kind of code before where you want to invoke an asynchronous task on the completion of another. So we invoke the asynchronous task in the callback of the previous one, and so on and so on. This is showing 3 callbacks deep. This is getting into what we refer to as callback hell. It can get difficult to read, particularly as you get to a larger and larger nesting level. So this is running asynchronous tasks serially. If you want to run them in parallel, you tend to do something like this. I have async task 1, async task 2. I will share a callback between them and have some state that I can track. So when I invoke the callback, I can check if both the asynchronous tasks are complete and invoke my callback there. So this is gross for a number of reasons. One, we have to track the state. Whenever we're tracking state, we have room for error. Another grossness from this approach, which isn't immediately apparent, but what about error handling, right? What if we call async task 1 and it results in an error? How is asynchronous task 2 going to know that. So we have to track that state. We have to do manual error handling. Try catch isn't going to work in this case with the asynchronous tasks running remotely. So if you've done any JavaScript lately, you know about the promise API, right? So promises gives us a good way to handle both these approaches. We can define a promise API for our asynchronous tasks, and then we can chain them nicely using the then method. Async task 1, then async task 2, and then we have our success callback that's invoked. And we have built-in error handling. If any of the asynchronous tasks result in an error, they will invoke our error handler. Similarly, the promise APIs provide a method for invoking asynchronous tasks in parallel using a similar notation. So the promise API works great for dealing with single events, like a XHR callback, for instance. You have a single invocation, a single resolution of your promise. What about multi-valued events, like keyboard or mouse events, where you have a number of invocations of your callback? Promises don't work so well in that environment. So just as the promise corresponds to the object as we go from synchronous to asynchronous coding, and the array corresponds to the object as we go from single to multi-valued code, we're going to introduce the observable as a means of working with multi-valued events. So what is this observable, Brian? So I like to describe or relate the observable to an array or a collection. We have a collection of events, right? So as you have a collection in space, they're objects that you can refer to at a particular instant in time. You have access to all the objects. A collection in time can also be treated as a collection. We just don't have a reference to all the objects yet. So in this talk, we're going to see how we can take the same functional tools that we use to manipulate our conventional collections and use them, apply them to these collections in time. So a brief description of imperative versus functional programming. If we think of iterating over a collection, in an imperative approach, you reach into the collection and you can get a handle to every single object, and you can take it and you can iterate on it, and you can do some tasks to it. In a functional approach, instead of the developer taking control of iterating through the components or the objects in the collection and iterating on them, we just tell the container or the library what it is we want to do on each object. We give it that function, do this on each object, and let it iterate over the objects in the collection. So if we take this functional approach, we can see how we're going to be able to use the same tools for operating on a conventional collection as with a collection in time. So to build on this analogy with collections and observables, I built this little visualization tool which lets us see a collection. Right? So this is, if we look at the JavaScript code here in this code pen, can you guys see that? It might be tough. You don't really have to get the details of this. Basically, we're creating an array of objects, which I then pass to my visualization code, which will draw out the blue, red, yellow, circle, cross, diamond, and squares. So here we see a collection, right? Is what we think of a collection. We have the ability to access, at the current time, every object in the collection. So if we now consider what an observable looks like, we can think of it like this, right? We have exactly the same objects in the collection in time. The difference being that we can't, at this current instance in time, grab a reference to every single object in the collection. So we're not able to iterate using a for loop over each object in the collection and operate on the objects. So if these are such seemingly different concepts, how is it then that we're going to be able to use the same tools on both? So at this point, I'll introduce the library Rx.js. So there's the Reactive Extensions project, which you may or may not have heard of. It's a project that's implementing a set of reactive extensions and a number of different languages. Rx.js is the implementation of these reactive extensions in JavaScript. And so it's a set of libraries that then allows us to compose asynchronous and event-based programs using observables. So we're going to go through a set of basic methods from this library, see how we can use them, how we can compose them to do some interesting things. The library itself is huge. There's a large number of functions that we can make use of in our code. We're going to focus on the basic building blocks, the ones that we're going to use almost all the time. And so these ones we're going to look at are the map, reduce, merge all, reduce again, typo there, and zip. So the idea of a map is when we have a collection, we want to iterate over every object in the collection and return a new object, usually based on that initial object. So in our examples, we're going to go over all our objects, our shape objects in the collection, and we're going to return a new object that's going to have the same ID. It's going to be the color green. It's going to be the same size, and it's going to be a square shape. Right? So pretty trivial. We should all be familiar with map, how map works. We can see how it works on the collection. We have our shapes on the side with color, shape, and size, and they all get mapped into green squares of size proportional to their initial size. If we look at the JavaScript code here, we can see the code to initialize the collection. And here, we define the output data is this input data with that same map we saw on the previous slide. So this code here, this piece here, we're going to see is exactly the same when we get to the observable. So with the observable, we have a stream of objects, similarly shapes of different colors and size, and we're going to map them into green squares of corresponding size. And if we look at the JavaScript code here, we can see exactly the same mapping function. The output data is the input data where we map on it. We take a reference to the object. We return a new object of color green and type square. Exactly the same code, same map function. So this, to me, is the compelling. You have a question?
Yeah. So I know when I keep hearing functional talks, it's like data is immutable.
Yeah.
Is that what's happening? Is that why? Is it immutable here too? Is that why you're creating a new array, or can you actually process it?
Yeah. So from my perspective, talking about like functional programming is kind of like saying you're a vegetarian, right? There's all sorts of degrees of how far you want to take it. When you do functional programming and you want immutable objects and you want to take that approach, that definitely works. In this case, I'm kind of using functional programming in the sense that I am passing functions in that I want to operate on my objects. And now whether or not they're going to mutate the state or not is kind of a decision you have to make. In JavaScript, these are not immutable objects. They can't be mutated. In this case, I am returning a new object, so I'm not messing with the original object coming in, but I easily could if I wanted to. So for me, this is the compelling piece between, or that we get with working with observables, is this idea that we can operate on them, on these events, as collections. Right? These are objects that we don't have a reference to at this moment in time, but when they come in and we get that reference, we can operate on them with exactly the same kind of tools that we would use to operate on in collections. So let's get on to the next example is the merge all. So we're going to take the same map function. In this case, we're going to create two objects. One is going to be the same shape and size, but we're going to change the color to green. And the other is going to be the same color and shape, but we're going to change the size. And now we're going to return an array, a collection of these objects. So the end result then, if we have started with an array, we're now returning an array. So we're going to have an array of arrays, which is kind of weird. right? So if we look at it like this, we have these individual shapes on the one side. We can grab a shape, move around that shape. Over here now we have these pairs of shapes. It's an array of arrays. Now this is not always what we want, right? We just want to be able to work with a single collection. This is more apparent when we're working with observables. So this is where we introduce the merge all function, which we see at the end here. The result of this map is passed to the merge all function. And what this does is it flattens the array of arrays. So if I take that same mapping and I apply merge all, I now have a single flat collection on this side. I've lost the array of arrays. I now have twice as many objects on the right-hand side as I have on the left-hand side, and I just have a single collection that I can operate with. So we see how that works with observables. And we see we have the incoming observable, or the incoming collection of shapes. And in the bottom, we have the mapped collection of shapes, and we see 2 shapes for every incoming shape. So this is using the merge all here. It's more compelling from an observable perspective than the regular collection perspective. You can imagine that having an observable of pairs of objects is not going to give us something that we can operate on easily. So merge all, you doing a map followed by a merge all, it ends up being such a common use case that we have an alias for it called flat map. Whenever you're working on a collection or an observable and you want to return a new collection or observable, we're going to use flat map. So we'll see that when we get to our examples shortly. The next one we want to look at is reduce. So reduce is a common pattern for operating on collections and taking an aggregate value that represents that collection. So here we're going to reduce our shapes. We're going to iterate over each shape, and we're going to accumulate the size and create, at the end of our iteration, a new shape that is proportional to the size of all the shapes in that object. So looks like this. We take the collection, we iterate over all the shapes, and we end up with one big green square. So again, taking a minute to look at the code. Click over here. We initialize our collection, define our shapes. This is where we're going to reduce it. We see the same code we had on the previous slide, and we're able to visualize that result. So we can also apply reduce and an observable to an observable. The catch being here that reduce only makes sense on a finite collection, right? If this stream of shapes keeps going on without end, then we're just going to keep accumulating, and we're never going to have our shape, our result of the reduce. So here we can see all the collections come by. After 80 objects come by, I terminate the observable, and we see the reduced square, the same big square that represents the accumulation of all the shapes in our squares. Is this clear? Are you guys getting a sense for the similarities between collections and observables? Does the visual help bring it together? Let me know if you have any, if you need any further clarifications. So the next one we're going to look at is zip. This is a function we want to use when we want to combine 2 collections or 2 observables. So here we're going to have the parameters we pass to this are the input data. So we're going to pass 2 collections, input 1 data and input 2 data. And we're going to pass in a function which describes how we want to combine them. So we're going to pass in 2 collections, and we're going to get the result, a single collection that is going to take the color from the first shape, take the size of the second shape, and then take the type from the second shape, and will result in a new collection. So looking at this, skipping looking at collections, just looking at observables, we see the 2 input streams on top. Refresh that. No, that didn't work. Don't want to refresh. Just give me 1 second while I get caught up here. Okay, so we have the two input observables, the one on the top, the one on the bottom, and then the resulting zipped observable on the bottom. So you can see we take the shape and color of the top one, and we take the size of the bottom one to create our new object. So this zip function is really useful when you have two streams coming in, two observables coming in, and you want to be able to combine them. I use this often with an interval observable. So you can imagine an observable that emits a particular event on a regular interval, and you can combine that with, say, a static collection, and then you can create an observable in time out of that static collection. So we'll see some examples of that later. Is there a question?
What would it do if like, the second stream missed a spot?
So that depends on the particular function that you're working on. The way zip works is it waits for an event. So you pass it two streams, it takes an event from one stream, waits for an event from the second stream, and combines it. So if you have one stream that's steadily producing events and another one that is more sporadically producing events, this one will buffer. It'll queue up and wait for the next observable to come in so it can make the pairing. That's how zip works. There's other functions you can use, merge, for instance, which will combine two observables into a new observable, and it just takes whichever observable comes in and puts it into the next observable for different use cases. All right, I'm out of.
If I have a whole bunch of mouse movements which are buffered in, I can kind of, what function would I need to say that only take the last function?
Yeah, we're gonna get to that exactly. We're gonna get to mouse functions shortly. I'll answer if I don't answer your question when we get to the examples, please ask again. I'm having a minor technical problem. My presenter has become unsynced here. Let me try relaunching this. There we go. So we did reduce, zip. So if we want to use observables in our application, something we want to adopt, we don't have to worry about this being just another proprietary API that we're going to end up with supporting in our application. The observable API has been submitted as a proposal to be included in JavaScript. So in the future, we can look to the observable pattern or the observable API being something or some form of it, some future iteration of it being available in our in JavaScript itself. So we can feel comfortable using it. That's my point here. So let's talk now about creating observables. We talked about how we can manipulate them. Let's talk about how we can create them. So we can use the Rx library to create observables. I call this the brute force approach. We take the create method, right? We pass in a function as the parameter to the create method, where that function will take some future observer, some undefined observer. Whenever we want to emit an event from that observable, we call the onNext method on the observer. When we want to complete our observable, we call the onCompleted method. Additionally, if there's an error that we want to propagate through our observable, we can call the onError method. So with this approach, we can take anything and we can create an observable out of it. So let's look at an example of doing that. Let's look at the mousemove event. So here I'll take observable create, pass in the future observer that this will get invoked on. I get a reference to my element. I add an event listener. And on every mousemove event, I will call observer onNext with the event parameter. So now I've created an observer for the mousemove events. I can now, to this observable, I can now apply my filters, my maps, my merge alls, my zips. I have the whole observable API able to work on this event stream. This is a little bit verbose. Thankfully, the Rx.js library gives us a number of helpers for creating observables, so we don't have to take this brute force approach every time. We have the from event helper, for instance, which allows us to create an observable from the mousemove event. You'll notice this was a rather naive implementation of an observable. I have no error handling. I have no completion events or anything. So doing a proper observable wrapper around the mousemove event would be more complicated. But the library has already done that and provided us this with the Rx observable from event call. So that is how we can create observables. If you have a number of helpers, you can create observables for a WebSocket connection. You can create observables as wrappers around node callbacks. Just about everything exists as a helper function to help you create an observable. Yep.
So what this actually does in practice is every time I have my mouse over the thought element, it's going to send an event?
Right. Yep. It invokes the mousemove listener on that element and creates an observable from that. And we'll see that in action in a minute. Let's just first talk about consuming observables. So we've looked at how we can manipulate observables. We looked at how we can create them. The last piece of the puzzle is to consume them. And we do this through the subscribe function. Right? So we take our mousemove observable. We can subscribe to it. And there's 3 functions we can pass to that subscribe method. The first is the callback function that we want to invoke every time there's an event. We want to know when there's an event. We want to do something. The second function is the error handler, which will get invoked when that observable produces an error. And the third is a callback function that will be invoked when the stream completes. So at this point, if we had all the time in the world, I would point you to this URL, tell you to work through the tutorials, get familiar with how all these methods work. We'll all come back on a base level of understanding, and we could work through the following examples. But we don't have time for that. So we'll move forward, assuming we're all intimately familiar with how these base functions we looked at work, and we're going to see how we can apply them. Do take the time, if you're interested in this topic, to work through this link. I have it linked again at the end. So let's look at a use case. Let's take that mousemove event, and let's duplicate the behavior we get with the jQuery on event listener. So if you're familiar with jQuery on at all, the neat thing about jQuery is you can pass it an element, and you can pass it a selector. So you only want to operate on events that are triggered that match that selector. So you use this if you have a giant table. You want to know when you say, move your mouse over any table cell. You don't want to register an event listener on every single table cell. You register the event listener on the body, and then you can put a CSS selector to the jQuery on method that restricts or that filters out all events that aren't for the particular table cells you're looking for. So we can replicate that using observables. We create our observables from the mousemove event, and we're going to use filter function. We didn't go over filter in our examples. I meant to include that one. Filters, it's pretty self-explanatory. It filters an observable based on a Boolean check you want to do on each element. So here we're going to filter on all the mousemove events. We're going to check if the particular event target element, if the class contains the particular class we're looking for, and we're going to return true. So the result from that filter is going to be an observable that is derived from the mousemove observable containing only the events that we are interested in. So here's an example. We look at the code here. Oh, I have to click here. We look at our code. We take the mousemove event. We're going to filter checking if the target class list contains blue. And if it does, in our subscribe function, we're going to record the date of that event, and we're going to update the display. So if I mouse move over the red one, we get no events. I mouse move over the blue one, I get events. And that's a single mouse move observable we registered on the body in this case. So if you ever wanted the jQuery on functionality while registering a listener, you don't have jQuery in your project for whatever reasons, and you're using Rx, you can fill in that yourself. So another example, let's look at drag and drop. We can implement drag and drop functionality using observables in an intuitive way. So the first thing we're going to do is grab a reference to our drop target, and we're going to create a number of observables. We're going to create a mouse up observable for the drag target. We're going to create a mouse move observable on the entire document. And we're going to create a mouse down observable on the drag target. Now with these observables, we can combine them to get our desired functionality. So what we're going to do is we're going to take our mouse down events. We're going to listen to all our mouse down events. We're going to use our flat map. If you remember, the flat map is the map followed by the merge all, right? So we're just going to map every mouse down event. We're going to map into a new observable, and then we're going to flatten that back into a single observable. So we don't have an observable of observables. So we take every single mouse down event. We're going to map it to a new observable event, which is going to be the mouse move. So our mouse down, as soon as we have a mouse down event, we're going to trigger the observable. Now we're going to start listening for the mouse moves after the mouse down has occurred. So that's here. So now we're going to take each mouse move and we're going to map it to return a new object that is just the left and top position of where our mouse is at that particular time. We're going to keep listening to the mouse move events until we lift up the mouse key, the mouse button. Right? So mouse down, start listening to mouse moves. We're going to take mouse move events until the mouse comes up. Right? So that answers your question earlier about stopping a collection. When we want to stop listening to particular events, we can use the take until method for that. So I like this example. It's really concise. Well, once you're familiar with the observable API, it's readable, right? I take the mouse down events, I map them into mouse move events, and I'm going to keep taking mouse move events until the mouse comes up. You'll notice I never had to register any event listeners, and I never had to unregister any event listeners. Right? If I was doing this in the traditional way, when I take my mouse up, to prevent memory leaks, I would want to unregister my mouse move listener so I don't accumulate a number of mouse move listeners, right? So when we're registering and unregistering listeners, we have the potential for memory leaks. That's state that we have to manage. So by taking this functional approach, we just say what we want to do with these events when they come in. We operate on them. State is taken care of for us, and cleanup is taken care of for us. I find it compelling. So let's take then that mouse drag observable and let's subscribe to it. We're going to take our drag target and we're going to update the position based on the position we've returned from that mouse move target, our mouse move event. So if we see this in action, I can pick up this shape. Grab it over here. Pick up the shape. So now the mouse down event, I start listening to mouse moves. Every time there's a mouse move event, I'm updating the object. I drop it. I'm no longer listening to the mouse move events. So we look at the code sample in here, and we can see it all come together. We create our observables. We map over the mouse down observables, returning the mouse move observable until we have the mouse up observable. So let's talk a bit about, move here. So why do we need that take until method that we saw on the mouse move, right? We're talking about terminating collections. Well, it turns out that we can talk about two different kinds of observables, right? We can have hot observables. These are just ongoing event streams. They just keep happening. Mouse move is like that. It just, as long as you're moving the mouse, you're going to have mouse move events. You can think of, you created a WebSocket to a stock market service, and you're getting events coming back every time the stock price is updated. That's an example of a hot observable. It just keeps spitting out events. A cold observable, on the other hand, is an observable that doesn't do anything until you subscribe. For instance, if we create an interval, an observable out of an interval, that interval is not going to count until we subscribe to it. So we have this notation that we can use to represent observables, right? The dots represent a progression of time. We have events that happen at different points in time. And we can represent the open observable, the hot observable as an ongoing sequence, and the cold observable has a definite finish and end. So how can we end observables? So if we have this hot observable, let's take the mousemove events. We can represent here as a collection in time. Right? We take a number of if we use the take method on it, and we want to take 3, we're just going to take the first 3 events from that observable that come along, and that new observable is then going to complete. We now have a finished observable. Any actions we do on that observable, if we're going to do reduce or we're going to do a flat map, it's going to only operate on that returned, shortened observable, one that completed. So we'll take 3 elements. We used take until earlier. Take until, we'll keep taking events until another observable fires. In that case, we took until the mouse up event fired. Let's take a look at another example, how we're combining this base functionality and introduce a few more methods. So let's look at creating an autocomplete observable. So here we're going to take an input element. We're going to create an observable out of the key up elements. And then for each key up element, we're going to want to map that element into something new. We're going to return the target value of that input element. Right, so as we're typing into an input, we're going to get an observable stream that is the values that are typed into that input. That's this first map function. Where's my mouse? That's this first map function here. The resulting observable, we will then filter. We're only going to fire observable events out of this next observable when the length of the text is greater than 2. So if I put in a single key into my input, I will not proceed past this filter. I will not trigger any events further along my chaining of functions here. The next one I'm going to introduce now is called debounce. Because it's kind of like filter. It's going to restrict which events proceed through our chain of observables here. We're going to debounce, pass it a parameter 750, which means it's going to wait for a pause in our typing. Right? So we're typing along. If we type really quickly, no events will make it past the debounce until there's a pause of 750 milliseconds between events. The next one we're going to use is distinct until changed. So if I hit, say, the shift key, that'll trigger a key up event, but it hasn't changed the value. So if the value hasn't changed, we don't want to proceed with our observable stream. It's not of interest to us. The last method we're going to evoke is flat map latest. It's a variation on flat map that will only return the most recent observable return from it. And so this is where we're going to do our search. So we have a helper function which will go off and issue a AJAX call against the Wikipedia API and return the values. So then we're going to get our observable stream now, which started with a key up event, which we mapped, filtered, debounced, and distinct until changed, and applied the flat map latest. That stream now is going to be converted into a stream of search results. Right? So we have our single object. We haven't had to track any state as we're going along through this. Everything just works. So let's see how this works. Here we have this input box here, which is where we bind our event listen to. And if I start typing, I'm now at 2 characters. I should get my autocomplete list is updating the list. So typing slowly, they all really come in quick. If I type really quickly, the debounce should not update the list until I finish typing. Right? So this is a feature-rich autocomplete. Right? We got debounce in there, so we're not firing AJAX requests with every single key press. We're waiting until there's a delay and updating the value. We have distinct until changed in there, so if I hit the shift key or the up-down arrow keys or what have you, I'm not triggering an AJAX request. Like this is is not a trivial autocomplete, but we managed to implement it with relatively few lines of code. All right, so here, if we look at the code, here's our little helper method, which does an AJAX call using jQuery here. Here we create the observable. This is the exact observable stream that we saw on the previous slide. And the last thing we do is we subscribe to that data that's returned from our observable from the last Wikipedia call, and we update the display with that. So that's compelling to me because we have some rich functionality without a lot of code. All right. So now I'd like to jump into looking at the Middleware Keynote demo. So you'll see this afternoon or this evening, if you attend the Middleware Keynote demo, you'll see a number of UIs that we built for the Middleware Keynote demo. These UIs were built using Rx.js to manipulate the data, along with D3.js, which is the same visualization tool you saw earlier that gave us the shapes. So let's take a look at the Keynote demo. And see if I can come over here. No. How am I going to do this? Okay, so if we go to beacon, jbosskeynote.com, so we're going to look at this particular visualization. So I don't know if you guys, when you registered, if you got one of these beacons that was handed out, these little blue beacons, IoT beacons, and if you registered your name with it, we've been recording the data. We have these Raspberry Pi scanners. You can see them by the door, the little glowing red light. So that has a Bluetooth scanner on it that detects these beacons. And then we take that result, we send it to a JMS broker. We process that incoming data with Apache Spark, put it back into a new queue, or new topic into the broker, and then this visualization pulls off that process stream and updates the map display with the location of that beacon scan. Right, so I mean, this to me is a compelling, I'm using that compelling word too much, but it is compelling. Taking these events from all these beacons, we have this large stream of data, and we want to manipulate that data and map it, filter it, and so on until we end up with a display on our map. So Rx makes a natural fit to this. So let's take a look at some of the code, some of the examples that we used in creating this display. So we're going to start, so the way this works is we have a Node.js backend, which I use Rx in. That's one of the nice pieces about Rx.js. You can use it in the browser. You can use it in your Node.js backend. And you get the same API for manipulating streams of events in both environments, right? If we've used Node.js before, we're familiar with the Streams API. It's pretty trivial to convert a stream into an observable, and then you can work with observables using the same APIs that you would be using in the browser. So here we have our Node.js backend. Here we're going to use the brute force approach, observable create, to create an observer for the stomp over WebSocket feed from our broker, from our JMS broker, from our JMS messaging system. So we had to use the brute force approach. Stomp is not a protocol. Well, I guess it's a well-known protocol, but it's not a protocol that the Rx.js team has decided they want to provide a helper function for. So we take the bare bones approach. We use the create function. Whenever we use the stomp over WebSocket library to create our stomp connection. Whenever we get a stomp message, where is it? Here, connect, error. There we go. So this first observable just deals with the connection, right? So we create the connection, we get back the reference to the connection, and we return that connection so that we can get our feed events then we can chain to that connection event, right? So we say we want the stomp web feed. Let's go ahead and create the connection. We return that as an observable itself, and then we can map on the connection to get our data feed. So in this feed down here, we take our connection observable, and we're going to flat map it with a reference to our server connection, and then we can create a new observable. We're using flat map, so we're returning observable and observables. So we use flat map to flatten that. And here now I trigger my on next with the message from stomp. So this is kind of hairy code. It's kind of gross. It's tightly coupled to the stomp API, right? I'm listening to particular messages from stomp. I'm dealing with how they manage subscriptions and how they fire events. So the nice thing now about wrapping this in Rx is once I've returned this at the end and I work with this feed, from here on, it's just an observable. It's an observable that fires events. I can map it, I can filter it, I can flat map it, I can reduce it, do whatever I need to do. I've encapsulated all the stomp specific stuff here. Right? So from this point on, it could be a regular WebSocket feed, it could be a mouse event. It's just an observable that I'm going to work with. And so what do we do with this feed? We take this feed and we're going to pipe it over a WebSocket. So here we're using the WSS library to create a WebSocket connection between the browser and Node.js. We're going to take that scans observable. So this scans observable is the events returned from stomp. And we're going to apply a number of Rx functions to it and ultimately send it using WebSockets as a JSON object to the browser. So some of the interesting things we use here, we use a buffer to create a collection of events, right? So if we have a number of collections come in quickly from the server, we can use buffer to collect those events up into an array, and then I can pass that single array of events down to the browser instead of overloading the WebSocket connection to the browser with too many events. So we're able to use buffer for that. Tap is just something we want to invoke on every element in the observable. Here we want to update the time, create some log messages, and then send the connection down to the browser. In addition, we get some neat functionality with the observable for error handling, right? So we can register the retry code on the WebSocket connection to the stomp over WebSockets connection. If that stomp connection fails, we can use this retry to retry it under certain conditions. We can retry it. In this case, I'm counting the number of errors. So keep retrying that connection until I have 5 errors, and then I can quit. So it's nice that error handling now is built into this in a standard way. So wherever I have an observable, I can use the same retry logic to record there. So let's take a quick look at some client code. I don't see this on my display, so I'm having a bit of a tough time here. Map.js. So how does this look on the client if I have it open? All right, so here on the client, now this is JavaScript that runs on the client. We're no longer a node, we're in the browser. Looking for the Rx.js code here. Oh, no, I'm in the wrong one. Okay, here we go. So here we create an observable using the Rx DOM from WebSocket helper. So this creates an observable out of a WebSocket connection. I didn't have to use the create, didn't have to do the brute force approach myself. This is a regular WebSocket connection that the Rx people have provided us this helper for. But you notice I'm using the same retry logic that I used on the server, right? I got my retry win. Here I refactored out the retry function, again counting the number of retries that I've committed and continuing to iterate on this observable until the retry count is exhausted. But the point not being the details of the retry code, but the fact that I'm using the same retry logic in the client WebSocket connection as I'm using for the stomp WebSocket connection on the Node.js server. Right? It's the same API, it's the same paradigm. And so then I can take this stomp feed, I filter it, I look for scans, and then I can update the map based on the values returned from our JMS broker, which the data originally came from these scanners. So it's kind of neat to see the progression of the data from the beacon event being scanned at the Raspberry Pi, going to the broker, going to Stomp, coming to Node.js, down to the broker, a nice stream of events. So with that, let me get back to here. No, that's not going to work. Launch. Okay, so image references for the images I use. So in conclusion, I'd like to just wrap it up by saying Rx.js is really cool because it allows us to create complex asynchronous applications as a composition of really simple functions. Right? We get complex behavior with the same set of base functions that we can reapply. So if you're interested in learning more, feel free to come talk to me about it. There's the Learn Rx resource. It's a little interactive JavaScript tutorial that'll go through the same analogy of collections and observables and help you learn what observables are. I linked to a YouTube video. This is what first got me turned on to observables, got me excited about it, wanted to learn about it. Check out that YouTube video. I linked to the Rx.js project on GitHub. And finally, if you want to follow me on Twitter. And that's it. Do we have any questions?
So I find the hardest thing for me is to think in, once you see the functions, but how did you just do it a lot and that's how you learn?
Yeah, so you'd start with those same base functions and then you'd want to do something. And then you're stuck. Well, how can I do this? I'm now in this new paradigm. I can't use my old way of thinking to do it. What I would end up doing is I go to the Rx.js website. I'd look at their docs, look at their API on the observable, core, observable, and I started looking through these list of methods and reading the descriptions and saying, okay, what is it that I want to do? You know, there's fork join. You can go and run two asynchronous processes, wait till they both complete, get an observable when they're both done.
Yeah, I know, but mine's even like a meta level higher than that. Like I think in the implicit way.
Mm-hmm.
That's what I've been trained in. Everything about my brain is I'm going to loop through this thing, or I'm going to do. It's like why I like using the DOM rather than using SAX. Like this is SAX versus the DOM.
Okay. Yeah.
So I just have a hard time getting my head into that space. Like,
Right.
what is the way?
So the way to start then is with that tutorial. Right? You go through the tutorial, and it introduces you to these concepts and kind of gets you to see the power and expressiveness that you can gain. And then, yeah, you just start using it. You start using it, you start finding new ways of thinking about it, and you'll find you don't want to go back. That's what I found.
One way that helped me to gain understanding and thinking about functional programming is to learn a language that's purely functional that doesn't allow you to do anything else. So if you were to try Clojure or Scala is partial. You can still do it Clojure is a little better. Or Elixir. Go for some real pain and learn Haskell.
Any other questions? Go ahead.
You were contrasting it with eventlessness that you unregister to avoid your memory leaks.
Right.
I wondered with the observables, especially if they're buffering out events and some examples that you have, like what is the scope of those
Yeah, I mean, for sure. If you have a voluminous stream coming in and you're trying to buffer the whole thing, yeah, you're going to run into memory constraints. Sure. So you're going to want to make sure you take that into account, right? If you're going to have events coming in faster than you are capable of dealing with those events, then you're going to run out of memory. So you might want to apply a filter ahead of time to filter down those events before you buffer them so that you're only now buffering what you're actually able to consume. You're going to have to come up with some strategy of dealing with that.
Sure, I actually meant when you were doing like the observable create.
Yeah.
Sometimes without assigning it to a left-hand. Like what is the scope of that on the observable?
Right, so when we subscribe to that, we create a subscription object, and that subscription will stay around until that stream completes, or until we dispose of the subscription. So when a stream terminates, it cleans up after itself, right? It'll unregister any listeners that were registered in the creation of that observable. It will take care of its own cleanup. So in the case of the mouse event listener, if we terminate that, or just dispose of that subscription, or if we terminate that observable, it has code in that create function that will unregister the listener for us. So it's not that the listener doesn't get created and doesn't get unregistered, it's just that that's something that I don't have to take care of. I don't have to keep track of that state myself. Right, yeah, and if you don't subscribe to it, the observable, that's an example of a cold observable. It will never get created in the first place, yeah. Yep.
Philosophical question. So when you start to look at Rx or JavaScript or Java or whatever, everything starts to look like a string, right?
Right.
Did you get some kind of feedback on how far you could go far? You use that even for synchronous API that might become asynchronous at some point?
Yeah. So that's definitely how I ended up going through this list, is I would be pushing the limit on my understanding of how to manipulate these streams of events, these observables in time. And I wouldn't know how can I carry on with this paradigm without falling back to my usual way of programming. And I've always found a solution. There's always some way of doing it, often revolved like a rejig, a re-way of thinking of the problem, but I was able to come up with the Rx approach to solving that problem. So. And then the more you do that, the easier it is, of course, and you can carry forward solving new problems with the tools that you've gained.
And looking back at the code you would have produced before, did you at some point realize it's an overhead reading-wise compared to the old way? Or?
No, so from my perspective, I've done things that I just never would have tried ahead of time. I've combined events in different ways. I didn't get to it, but one thing I do is I create an observable reading back events from a file, and I zip it with an interval to get a real-time playback of events in a log file as an observable stream that I can then play back in the UI. Like I just that kind of thing, I just probably would not have even approached it with the conventional program. It would have just taken too long, would have been too time-consuming. But everything was there. I just had to recombine things in different ways and take advantage of what I already had to be able to gain that kind of stuff essentially for free. And then once I learned that pattern, I was able to apply that to other solutions, other projects, other UIs. Okay, it looks like we're out of time. If you have any further questions, feel free to come up. I'd love to talk about this stuff.